So on to problem number 10 of the MIT Integration B qualifying exam 2017, which is the definite integral from x equals to 0 to x tending to infinity of 1 over the square of x plus 1 over x. So let's see how we may be able to solve this. Actually, a very interesting problem. Let's see how we may be able to solve this. So this is our problem. From x equals to 0 to x tending to infinity of 1 over x plus 1 over x squared, right? Let's see, how do we solve this? First thing I would do is I would so it will be squared over 1 over x squared, and this becomes 0 to infinity of x squared over x squared plus 1 squared. And then let's use a trigonometrical substitution. We say let x be equal to tangent of theta such that dx d theta is equals to sec squared theta, and so we can substitute for dx with sec squared theta d theta. So that is one thing. And then let's look at the limits. Moving from x to theta, when x is 0, the arctangent of 0 is going to be 0. When x tends to infinity, the arctangent tends to pi over 2. Okay. So what does that lead us to? So if we have now 0, infinity, x squared plus 1 dx. This is from 0 to pi over 2 in the theta domain. X squared becomes tan squared theta, and then tan squared theta plus 1 squared dx becomes sec squared theta d theta. So this becomes 0 to pi over 2 of the tangent squared theta. Sec squared theta becomes sec squared theta, all that squared, and so we are left with one of these cancels with one of that. We can say that, and so we are left with the integral from theta equals to 0 to theta equals to pi over 2 of tan squared theta over sec squared theta. And so 0 to pi over 2 tan squared theta over sec squared theta means that if we have 0 pi over 2 sine squared theta over cosine squared theta divided by 1 over cosine squared theta means that we have something to the effect of right, and that would cancel out, and so we are left with an integral from theta equals to 0 to theta equals to pi over 2 of sine squared theta. And we know cosine 2 theta is the same as 1 minus 2 sine squared theta, and therefore sine squared theta is the same as 1 minus cosine 2 theta divided by 2. So using this relationship, we can say our integral comes to a half 0 pi over 2 to 1 minus cosine 2 theta, which is a half theta, a half sine 2 theta, 0 to pi over 2. So which becomes half pi over 2 minus a half sine pi minus 0 minus a half sine 0. So this all goes to 0, this also goes to 0, and we are left with a half times pi over 2 is equals to pi over 4. So what that essentially tells us that the integral from x equals to 0 to x tending to infinity of 1 x plus 1 over x squared is equals to pi over 4. And for those of us who may be interested in knowing how this graph looks like, it's something to the effect, something like that, right? As x tends to infinity, this becomes larger and the entire thing goes to 0. But as x is small, so in between here, between when x is very small and x is so large, you get our local maximum. And they're all positive because we have that square interacting there. So this is our plot, and we needed to do to get the area for under those lobes. So that's it for us. There may be other methods of solving this, but yeah, that's the quickest way I found. So until next time, bye bye.